stealth technology, the internet, GPS in the palm of your hand, autonomous operation.
Technology is a driver of our times. Since its founding in 1958 in the midst of the Cold War, DARPA, the Defense Advanced Research Projects Agency, has been a driver of technology. Welcome to Voices from DARPA, a window onto DARPA's core of program managers, their job to redefine what is possible. My name is Ivan Amato, and I'm your DARPA host. And today I'm pleased to have with me in the studio Mr. David Gunning, who since late 2015 has been amidst his third tour of duty as a program manager at DARPA, in this case with the Information Innovation Office. During his previous tour, in the early years of the new millennium, David managed the Personalized Assistant That Learns program, PAL, that led to the now familiar voice of Siri. During his first tour in the 1990s, he managed a variety of AI projects, artificial intelligence projects, including the Command Post of the Future, which was later adopted by the U.S. Army as their command and control system for use in Iraq and Afghanistan. Between his stints at DARPA, Mr. Gunning played a variety of professional roles, among them Program Director for Data Analytics and Contextual Intelligence at the Palo Alto Research Center, PARC, a number of founding and managerial roles for tech companies, and as a senior scientist in the Air Force Research Lab at Wright-Patterson Air Force Base. The thematic threads throughout his career have been artificial intelligence and human-computer symbiosis. It's a thread that goes back to his education. David holds a pair of master's degrees, one in computer science from Stanford University and another in experimental psychology from the University of Dayton. David Gunning, thanks for joining me in the studio today.
Yes, glad to do it.
So like many here at DARPA, you work at the intersection of different mindsets, skill sets, and tool sets. In your case, the intersection seems to focus on humankind, computerkind, and the ways these two creatures can work together. Where did those interests come from? And go back as far as you can when you answer that.
Well, I can go back to the originating event that started DARPA. Sputnik in 1958. I was 8 years old, living at my grandfather's house out in the country, and I can remember him taking me out on the yard at night to see the light of Sputnik as it's flying overhead, kind of conveying what a shock this was.
And David, where were you to complete the setting?
In Covington, Kentucky, outside Covington, Kentucky. And so that, at the time, also not only sparked DARPA, but sparked a huge interest in technology. There was a huge interest in encouraging young minds to be interested in engineering and science. So I can remember that as kind of the spark that started it. Later on, I was in Otterbein College in Ohio in the late 60s, early 70s, during this kind of rapid change and a lot of cultural change going on. I became very interested in psychology. So that was my first technical interest, just how do people work? Right? People are clearly the issue in most of the problems we have today, and how does that mind work and what could we do about it was the starting point. And then I did that, got a master's degree in psychology, started to work at Wright-Patterson Air Force Base as a human factors engineer, which was one of the practical uses of that psychology degree I had. And then very quickly, the first jobs I had were to look at the human factors of how they were introducing electronic displays into the cockpit. This is in late 1970s, kind of one of the first workplaces to be automated, if you would. Pilots were getting the most advanced technology. They're putting in electronic displays in the place of instruments. Pilots are making microsecond life or death decisions. You want to make sure they get just the right information in just the right way, to make those decisions. And so that triggered my interest in computer science, because quickly became apparent that all the important aspects of this job were in computer software. And so that prompted my interest in computer science, then went back to school to Stanford to get my master's degree in computer science, and especially in AI. That was one of AI's summers, if you will. There was in the 1980s, a lot of interest in expert systems and one of the first waves of AI. And so that captured my interest and certainly was aligned with my background in cognitive psychology.
David, as I noted in my introduction, you're now in your third tour as a program manager here at DARPA. Just a little later, we'll talk about the programs you inherited in this latest tour, Communicating with Computers, and the program that you initiated, Explaining AI. But before we get to that, I'd like for you to take us on a brief tour of your prior 2 times as a program manager. So let's start with how you and DARPA met for the very first time as a PM. I guess this was in 1994 in the Information Systems Office.
Well, as I said, as I started off as a psychologist, then switched to computer science. In both those roles, I was a researcher at the Air Force Research Labs at Wright-Patterson. So doing a lot of work at the time on the F-22. That was the latest fighter aircraft of the day. Now those computer displays that started, in the 1970s were very advanced. And in particular then, I was working on a integrated information maintenance system. So now it was possible for the maintenance technician to walk up to a computer, walk up to the aircraft with a portable computer, plug it in, download information about what failures had occurred, get all of his tech manual instructions presented on the computer, create kind of an integrated workplace for the maintenance technician to help him do his job.
And just a question about that, because now when you go into any garage to have your own car looked at and diagnosed, there's a system very much like that.
Yes.
But this preceded that.
This preceded that. It was actually the very first prototype of electronic maintenance instructions anywhere. The services did that at that time on my program. And so I was doing that work. That got the attention of the general who was running the F-22 program. He pulled me into the F-22 to kind of manage and coordinate the development of all of his digital technology. And while I was there, some people from DARPA came to visit to try to convince this skeptical general that they should listen to DARPA and adopt some of their new technology. So he expressed how skeptical he was in a pretty graphic way and said, if you're going to do something on the F-22, you need to convince Dave Gunning. He's my guy on computers. That was with Steve Cross, who was deputy director of one of the offices, Geo Wiederhold, who was a program manager here on loan from Stanford University, who was doing a project in intelligent integration of data systems using AI. And so I began to interact with those guys, and when Geo left DARPA after his tour was done, then they invited me to come to DARPA to be a PM in 1994.
I find that interaction you mentioned with the general quite interesting because it reflects a conservatism that the services have because they want to work with tried and true systems, and it's a bit scary bringing in new technology, which does not have as much of a track record. But then you were there as someone really a champion of the new.
Yes, a champion of the new in a very conservative environment. And it's not that they're technology adverse. These people are very serious engineers. They're building this aircraft with enormous life and death, consequences if it's done incorrectly. So they don't want to put anything in that airplane, right, unless they really know that they can depend on it. That gave me a really solid understanding and background of where those people are coming from when you're trying to introduce new technology, and what you need to do to convince them.
One thing that I noticed regarding this first tour of duty is that not only did you come here, but you went full mind and body in. If I'm reading your background correctly, you were overseeing 9 programs, or at least in your period of 6 years in that first tour, there were 9 programs under your wing.
Yeah, that's right. I was starting 1 or 2 new programs a year, inherited a few, from other PMs, but I was all in. I was a lot younger then, had a lot more energy, but just loved the job. As you mentioned, I've been here 3 times because to me it's one of the most fascinating jobs you can have. You're at the pinnacle of new technology development. You have such a broad view of what's going on, and DARPA gives you this incredible freedom to pursue what you see as a vision on where things should go.
Now, one of the standouts from that first tour is known as Command Post of the Future. And that one actually did get out into the field. So just briefly, could you tell us a little bit about what the goal of that program was and in fact, how it unfolded in the field?
Of course, my interest has been in AI all along, and most of those 9 programs I ran in my first tour had to do with knowledge and reasoning, planning, trying to provide intelligent decision aids to people. So we created Command Posts of the Future, as a way to see if we could explore all sorts of AI technologies, see what worked, package that up into a system that Army commanders could use out in the field. So we started that with a wide variety of technologies of varying degrees of maturity and risk. And by the time we got to the end of the program, and I had left DARPA by then, and there was other people had taken it over, but the technology that survived was something that was, you might call adaptive or intelligent visualization. A lot of the more higher risk AI techniques had actually kind of fallen out as too immature, right? But they had, through a lot of iteration with some visionary people from the Army, Marine Corps, and Air Force, had really kind of picked out the nuggets of new technology that were incredibly valuable. And it basically was that if a commander and his staff could each have their own view of the battlefield in their command post of the future screen. So the operator saw the plans for the attack. The logistics guy then saw what did he have to do to support that plan. Right? The intel guy just got to see what information was coming in on what the enemy would do next. And one of the commanders, Army General Corelli, who was the one who championed it and took it to Baghdad, actually said that by watching his staff's command post of the future screens, he had a better idea of what they were thinking than he did if they were all in the same room talking to each other. So it enabled them to, one, be distributed, which is very important for the battlefield, but two, gave him better insight into what his staff was thinking and where how the battle was emerging.
So fascinating. This then is a case where the human-machine interaction summed into something more than the components.
Yes. And part of the critical part of that program is the way we set it up was to have, it was constant iteration between the technologists and the visionary users, right, which is, now called agile development. There's a lot of names for this, pretty much been adopted by Silicon Valley as a religion, but that strategy was pretty early in those days. And they had a lot of exercises where they'd take the researchers from the university, send them down to Fort Polk in the Army and actually put on the Army gear and run them through exercises. So they got a real sense for what the problem was. But they also had exercises where the visionary military guys would work closely with the technologists to try to sort out what was the most valuable thing the technology could do for a user in the field, and not just let the technologists kind of hypothesize what that might be with a somewhat naive idea of what's needed.
So in 2000, you leave DARPA, you go and do other things. And in 2003, though, you come back, and this time you're in the Information Processing Technology Office. Tell us a little bit about the programs that you ran there, including one that I think many listeners will have heard of.
Well, it came back, as I say, Tony Tether just come in as the new director, Ron Brockman as the office chiefs of this newly formed office, IPTO. And IPTO was also the name of one of the original DARPA offices, led by Licklider, is really where the personal computer was created, where a whole idea of, at those days, a computer meant a large IBM mainframe.
And just for listeners who don't know, so Licklider is a giant in the history of DARPA. He's known usually as JCR Licklider. It actually stands for those initials, Joseph Carl Robnet Licklider. And he really brought in an ethic of this idea that the human-machine interaction and a symbiosis was going to be a long, long theme of technology from then in the 60s when he was here until now. And so, David, you continue in this tradition.
Exactly. And before he came in, what a computer meant was an IBM mainframe that took up the size of a small room. And people would interact with it by sending punch cards into a punch card reader and getting an answer back on the other side. There was no concept of this being a personal computer you'd sit down with and interact with on a daily basis. And it was actually under his program as Alan Kay, who was at Stanford at the time and later at Park, sketched out the first diagrams of what we recognize today as the personal computer.
Right, and Park being Palo Alto Research Center.
Exactly, right. And so anyway, so that was IPTO. So Tony Tether and Ron Brockman, they really wanted to bring that back. They wanted to re-energize DARPA to go after the next generation of human-computer symbiosis. And the phrase then was cognitive systems, cognitive technology. And so Tony believed in investing big in this. And so we came up with the idea for this program called PAL, Personalized Assistant That Learns, which even by DARPA standards was a fairly large program, $250 million over 5 years. And it had multiple levels. At one level, it funded 20-some research universities and agencies around the country to explore a lot of cutting-edge technology in AI, in particular machine learning. Machine learning is now commonplace today, was just kind of emerging technology in those days. So it funded a huge amount of basic research on machine learning.
And let me just stop you for a second for listeners who might not really know what that means.
Okay.
We can't go into a full
Sure.
seminar about that, but how would you define that?
Well, in the earlier days of AI, we tried to develop intelligent systems by having people program rules or statements into a system that would tell it what the knowledge was and let it then reason with that.
And this expert system was a language
Expert
at that time.
systems and knowledge bases and TurboTax today is kind of a current incarnation of
And the
that
chess playing
technology.
programs.
Chess
were early
playing
ones.
programs, exactly. Those ended up being very difficult. It's very difficult to program, very difficult to maintain. It's very difficult for people to actually specify exactly the logic rules that are behind intelligence. But over those decades, and especially during this PAL program, began to realize that if you fed a computer a lot of data and turned it loose with the right machine learning algorithms, which were kind of learning the statistics and probabilistic nature of the data and learning different recognition patterns, the computer could learn its own patterns that were not specified by a person, but those patterns were much more effective at doing a lot of jobs than like understanding speech or recognizing images or, finding credit card fraud or et cetera. And so machine learning was much more effective than the older style explicit logic rule specification.
So in a sense, what the computer was doing is taking those sort of analog signals that we humans are comfortable with, but looking them now in their data versions.
Right.
And that's what they're comfortable with.
Yes, exactly. And so that was a big component of the program. But we also did a lot of work on man-machine dialogue, on, how do you carry on an intelligent dialogue with the computer? The speech understanding to some extent was already being developed. How would you have a computer that could be an intelligent assistant that would watch what the user is doing, understand his job, then be able to give him assistance at the right time? And one of the metaphors we used is you wanted to create an assistant that was like Sergeant O'Reilly on the old TV show MASH. For those of you old enough to remember, O'Reilly always knew what the colonel needed before the colonel knew himself, right? So he just followed the context of what the user was doing, could anticipate and provide intelligent advice. So that was the grand vision, and we funded a lot of very advanced research in all of those areas. And then one of our performers was the SRI International out in Menlo Park, California. They were one of the integrators of this. They looked at all the research that was being developed, tried to create a prototype of this PAL system that could actually be used as an intelligent assistant on your laptop.
So they were looking at many of the component technologies that the other performers were developing and seeing how can we put this together.
Exactly.
For
and that was really their job, was how do we integrate the best of all these techniques and put that together in a real prototype of a cognitive assistant. And so they, as long as they were doing that, began to develop a kind of streamlined, more efficient version of that architecture. And when the PAL program, the research version of the PAL program ended around 2008, they had several of the people who'd worked on PAL and some new performers they brought in formed a venture called Siri. And they decided they were going to take this technology, adapt it for the iPhone, which was a brand new product at the time, and people didn't know quite what to do with it. SRI was very wisely said, this is the place for a cognitive assistant. People are going to have this phone. They won't have a keyboard. They're really going to need an assistant that can help them out. So they had this venture, and for 2 years it was just funded as a new startup. DARPA then was out of the picture. They got venture money from Silicon Valley to develop this. And then 2 years later, they put their first Siri application on the App Store. The App Store was brand new. And I think it was 3 days later, they got a call from Steve Jobs himself, who said, and first they're like, well, sure, this is Steve Jobs, right? He just calls up on one of the random phones, in the office. After they began to believe it really was Steve Jobs, he asked the three founders, he said, why don't you come over to my house tonight for dinner? I've got a vision for what I want to do with Siri. And then there was some negotiation over selling the company. Apple bought it, spent several years developing it into the Siri assistant we know today. And for the first year of that, Steve Jobs was personally involved in directing it. He had really seen that as a vision for where he wanted to go, but then got too ill to continue.
Okay, so before we move on now to your current and your third tour, what you described here was sort of the archetypal technology development cycle at DARPA when it's about as successful as it can get, which is to say, you and others here and your performers, those who worked under contract on your programs, they brought a technology to a point of proving it and then taking the risk down enough that, say, other corporate entities or the military services can take a handoff and do the final development until we actually have the product technology. It's not often that DARPA goes to that point of a product technology, but it's more to that prototype or the proof of principle. Here's a case where all of this work that you did led to something that now is part of the technoscape of the world. So the question I have for you is just, what does that feel like? I mean, here you are, you hear
right.
Siri all over the place, and you know that you had a role in the sequence that led to it. So how does that feel?
Well, it feels great. And it was quite a surprise in a way, right? As you say, that's DARPA's job. We're always doing this advanced technology. We're always trying to reduce the risk, and we knew a personal assistant that's been a part of the AI science fiction since 2001 and Star Trek. And that's always, it's like, well, certainly we'll be able to talk to our computer someday, but it never quite worked.
But we don't want a HAL 9000.
Yeah, right. A benevolent version.
We want the pod bay doors to open.
Right. But the idea of a computer that was intelligent enough to carry on a conversation and be an assistant had been around for a long time, but never implemented. When people tried it, it didn't work well enough. It was always a little bit too kludgy. And I think that PAL program really brought it to the point that Steve Jobs was willing to take a risk and say, yeah, I can make a real product out of this. And like I say, I left DARPA in 2008. It's 2 years later that this comes out. And we knew Apple had bought it but had no idea what they were going to do. And then suddenly it's Apple's marketing department is advertising the product of my program. And that was very nice. My children even thought I was a cool guy momentarily.
The greatest achievement of all.
Right, right.
So let's then move now to your current tour of duty. You came in here in 2015. So you left in 2008. You went away. You did other things in industry. And you came back in 2015. So again, tell me that approach, how it is that you were convinced to come back a third time. And then we'll talk about your two programs.
Well, one, as I said, just being at DARPA is the best job I've ever had. Right? It's interesting to go out in industry. It's interesting to be in other places. But if you enjoy technology and you really want to make an impact, there's nothing like being at DARPA. So I was, had been out for a while in a variety of jobs in industry. I was kind of ready to looking for something to do. The other factor, though, is my son, who lives in Roslyn nearby, just had our first grandchild. And so that convinced my wife it was worth moving from Seattle, where our base is, back to D.C. So I got a great job. My wife got to play with our grandson all day. So that's what did it.
Pure justification right there. No need for anything else. So let's talk about the two programs. One you inherited, that's Communicating with Computers, right. CWC.
Right.
Just tell me a little bit about the goal of that.
Well, in a sense, it's kind of do the next generation of Siri and Alexa and those sorts of things. Where now that technology is there. It can understand what you say for the most part, not always, but for the most part, and can provide, minor assistance, can set an alarm, can play a song, right, help you find directions. In CWC, we really want to raise the level of intelligence and partnership of the computer so it is really an intelligent partner that's, a joint partner with the human. It's really human-computer symbiosis, not human as the manager and computer as a low-level assistant. So that's the goal.
Let's stay here for just one more minute. What's a kind of question that I might be able to ask after a successful CWC, communicating with computers program, that I can't ask, say, Siri now?
Let me not use Siri, but use one of the examples from the program, is the Harvard Medical School, where they had done some work on a previous DARPA program called Big Mechanism, where they're trying to create a system that could read masses of research in biology and then automatically construct models of cancer pathways. Instead of had the human biologist having to read thousands of research articles, the computer would do it themselves and create suggestions of new pathways for how cancer behaves in a cell, so the biologist would have that as a suggestion. So now the CWC part of it is, can we put a collaborative user interface on top of that? So now the biologist can collaborate with the computer to hypothesize how cancer works in the cell, to design experiments, so the computer is working as a virtual scientist, a lab assistant, if you will, or a grad student in a biology lab who's really helping to digest the literature, pull out the important nuggets, and suggest experiments that should be done.
I'm getting this now, I think, right? But the value added is, if I'm a scientist and you're a scientist, and we each spent a month immersed in the literature, you've read 100 papers and I've read 100 papers. But if I'm working with a computer, the computer might have read 10,000 papers or 1 million.
Exactly. And now it has enough intelligence and has the right kind of dialogue machinery so it can carry on a much more intelligent conversation with you about that. Today, if it was Siri or, concurrent technology, it might find me articles on, a certain pathway, right? Or find me articles about a certain protein, and the computer could do that. But it's really not going to absorb that information, integrate it, and then carry on kind of a more give and take conversation with a scientist.
All right, so now let's move on to the program that I suspect is taking up most of your time, because if the number in my mind is correct, you have at least 11 performers on this. And this is called Explainable Artificial Intelligence, XAI. So talk about the impetus for the program, I guess, first, and then talk to me about the status and how it's going.
Well, first, as I said, I came back in 2015, I talked to then Office Director Dan Kaufman about coming back to DARPA. And so as your listeners probably know, when a program manager comes to DARPA, the question is, what's your vision? What project do you want to do? That's kind of the job interview.
And you better do it fast, because you already have your sell-by date on your badge.
Right.
You're here for a few years.
And so Dan had actually suggested this idea of explainable AI. I had just been to a workshop with a group of Intel analysts from DoD, and it was a group of machine learning and HCI visualization people who were trying to convince this group of all the great new technology we could provide to help Intel analysis. And one of the ladies there, who was an analyst at one of the DoD agencies, said that's not her problem. Her problem, she already has big data analytics systems that are recommending, suggesting patterns or targets or, suspects to her. But she has to put her name on the recommendation that goes up the chain. And she gets graded, if not punished, if that recommendation is wrong. And she wanted these systems to explain to her their rationale for making the decisions they make.
This was for her how she was going to trust the machine.
Right. Trust it and when is the machine, when is this a false alarm? When is it a positive example I should trust? And to her, having the explanation was what's really needed to make that happen. And so that resonated, and it's about that time is when the new wave of AI, which is deep learning, is taking off, right? And you hear about this whole kind of new revolution in AI that's all about these deep learning techniques, which are kind of the most advanced of this machine learning technology we talked about earlier, where it takes in huge volumes of data, these deep learning systems that are very large neural nets with millions of neurons, if you will, that are each learning weights that help it build a model of what's the correct decision in any situation.
Electronic versions, of course.
Yeah, exactly. But they're incredibly opaque and difficult for people to understand. Even their developers are not quite sure how these systems are making their decisions. They can be incredibly accurate. They're fed enough data, and the data fits the world in the right way, they can be very effective, and now are incredibly effective at analyzing faces and objects and images and voice recognition and computer games, but they're not very explainable. It's not very easy for a user to understand what these systems are doing. So for a lot of applications, that's okay. If you're finding cat videos on Facebook, an explanation is not critical, right? But if you're an analyst for DoD that's picking out targets to investigate, or you're running an autonomous unmanned air vehicle that's going to go off onto a mission on its own, you really want to get a good explanation of what this thing is thinking. So it's a very hard problem. To some extent, this machine learning technology works so well because it learns models that are inherently more difficult, more complex than what a person would specify. But yet you need to get some explanation out of it so that a user can get an intuition for what the system is doing. So that's the problem. So we laid that out as is typical then at DARPA. You talk to a lot of researchers and a lot of people in DoD about the problem. You craft your solicitation, and you get in your proposals, and you pick your performers. And as you've mentioned, I've picked 11 performers who are each developing what I'm calling an explainable learning system. So we still want it to be a machine learning system. We don't want to go back to the old version of technology where you're trying to specify the rules, although in those older versions, they were more explainable. Because a human had described the logic it's using, it was much easier to regurgitate that logic to another human, and people could understand what it's doing. But in this case, that's not possible. So each one of these 11 teams is developing two major components that they're going to plug together into a system. One component is a modified machine learning process. So they're changing the deep learning process, or they're adding a new learning technique, or they're changing something about the way the system learns its model so that it's more interpretable, more explainable. And the second piece, going back to my background in HCI and psychology, is to have an explanation interface, which is the best combination of visualization, natural language generation, creates just the right explanation that's appropriate for an end user so he understands what the system is doing, even though that end user is not going to be a machine learning expert. So he has to take the complexity of this machine learning system and create the right kind of explanation so your average user can understand what it's doing.
So a question about that, and this really comes from the human side. So I might do something, behave in a certain way.
Right.
And then somebody might say, why did you do that? What's the explanation for your behavior?
Yes.
And I can come up with one after the fact that sounds reasonable to me.
Yes.
But I can't really be sure that I'm not fooling myself into just maybe I've just made up an explanation. So can't that be happening here?
It can. It's called rationalization. It's actually one of the techniques we're using. Some of the teams are taking an approach where they're going to treat the machine learning system as a black box. They don't know what's going on, but they can experiment with it. They can run 1 million simulation trials with different inputs and see what are the outputs, and then see if they can infer a model that explains what it's doing. So the test, though, we do to avoid the problem you're describing is does your explanation predict what the machine will do in a new situation? So if you're fooling yourself, the prediction will be wrong. And especially to help the user gain trust, so the user needs to have a model from the explanation so the user knows in which situation should they trust it and when shouldn't they. So they need to have some model that's, predictive of what the system's going to do so they can create this understanding in their own head, even though that understanding may be very different than what's actually going on inside the machine. It's close enough that it's capturing the main features of what the system is doing so that they can understand and have some faith in understanding what the system will do.
And another fascinating thing to me about explainable AI, and certainly as I'm learning from you right now, is it also seems to be rubbing shoulders with some of the great questions of philosophy. So it gets into an area of epistemology, right? A big word, which means how do we come to know things as human beings? And what is an explanation anyway? What's the nature of explanation? It makes me think that philosophers would be quite interested in what you're doing.
Unfortunately, they are, and I'll explain that. And we have the 11 teams are actually building the system, We have one team that's just a group of cognitive psychologists who are digging into what's known about explanation, not so much from philosophy, but from psychology. Psychologists for years have studied what explanation is more effective for a person, what explanation leads to learning better than another explanation, what explanation improves decision-making. So their job is to dig through all that literature and help us out with what's an explanation. And I mentioned about the business about philosophers' interest being unfortunate because it's so easy to get lost in this very deep conversation about what is causality and what's an explanation. And we've had a fair amount of that discussion in the program. I'm trying to get around that by using a very practical definition. The test will be if you create one of these systems, a human user has to use that system to make decisions, to manage an unmanned vehicle, or to do intel analysis. Does the explanation enable him to appropriately trust the system? Does the explanation enable him to predict when the system will be right and when it will be wrong? And that's our measure. So I want to try to avoid this philosophical swamp and just get to a practical solution on when does an explanation help a user do his job and when doesn't it.
So, David, you mean you want tools in hand in a relatively short time as opposed to 1,000 years of discussion?
Exactly.
Is that right?
1,000 years of discussion with no tools at the end.
Okay. So we're getting toward the end. We don't have that much time, but there are a few other things I'd like to just discuss with you. So one of them is, looking at the way artificial intelligence is received by the public, the kind of discussions the public is having.
Yes.
There is certainly some excitement. I think the public is leaning toward a positive view on, say, fleets of driverless cars that actually are working out there. There's still some concern about that. But there also is that dystopian side that artificial intelligence it's another kind of intelligence, and it's scary, and it might be more powerful, and that this is something to really fear and worry about. So you're in the midst of this. You are one of the tool builders in this AI space. And how do you think about that, the promise and the potential perils?
Well, that's a great question, and one that we talk about a lot. So first, AI, like any technology, can be used for good or evil, right? So there is both sides to it. And we have to be careful, right, to manage that. I overall think it's very positive, right? I think it'd be much easier for us to avoid the really negative aspects of this.
This is where someone might press you and say, well, but you're a technophile, right? And so you said that in a fairly cavalier way.
Yes.
So give me one or two bases for why you have that optimism.
Well, one is the level of intelligence we're really at in AI. So what we have, even though there's been huge advancements, especially in this deep learning technology in the last couple of years, we're so far away from human intelligence or anything that would be an independent superintelligence. That's science fiction. To me, it's like worrying about a meteor that's going to hit Earth sometime in the next 1,000,000 years and end life as we know it, right? It's not imminent, right? There's not a high probability. NASA should make sure they've got telescopes, around the planet so we can see that when it's happening. So we need a small number of people worrying about, let's make sure we don't create a superintelligence that gets out of hand. But I think the current technology today is so far from that, that's not a big concern.
So the dystopian endpoint is something, as you said, it's not worth worrying about too much now.
Right.
But on the other side, then, to move forward suggests to me that you think that the positive endpoints are really worth pursuing.
Oh, sure. Well, just like, say, driverless cars, right? That there's a lot of issues to be worked out there, but I have no doubt when that comes, there'll be fewer deaths on the highway than there will be with human drivers. Medicine, there are just huge advancements in applying this to medicine. I think one of the latest results was one of these deep learning systems can learn to recognize skin cancer events better than a human doctor. So just analyzing the vast amounts of data that we have and, being able to understand it, or just creating Siri and personal assistants that can do a better job. There's just so many things where AI is going to be useful.
Right. This is making me think of your new grandchild.
Yes.
He or she?
He.
So he is going to grow up in a time when AI is part of the landscape, part of the technoscape.
Right.
He will not know
Right.
a time without AI. That's kind of an interesting thought.
That's right. I actually have a great little video of him at 1 year old, his first interaction with Siri. And he's learned if he presses this button, the iPhone talks to him. And he doesn't even have language that we understand, but he would press this button and have a conversation in his own garbled language. It's just fascinating. So I think it will be interesting to see how this generation grows up.
Well, I think I'm going to want to see that video at some point, David. So we're out of time, and I just want to thank you for engaging me in really what has been an absolutely fascinating start of my morning here. Lots of things for me to think about for the rest of the day. So thanks a lot for being here, David.
Yeah, thank you. Certainly enjoyed it.
And thanks, listeners, for sharing this time with us. I hope you join us again for the next Voices from DARPA. For more information about David Gunning, the programs he runs, and the other breakthrough technologies DARPA is working on, visit darpa.mil. And for links that enable you to download this podcast, go to the Voices from DARPA page on DARPA's website.